Okay, so now we're going to apply our practice with different types of variables to the activities we did in class. So one of our labs, we looked at Oreos, and we were curious about the amount of filling. So when we think about, well, what were we changing in that experiment? We were changing the type of Oreo, right? We were looking at, were they regular or double stuffed? Like that was what was in our control, like what we were doing to change. What we were observing was the mass of each type of cookie and the filling. So we were recording that data, and eventually we graphed the mass of the filling between regular and double stuffed. And then what were we keeping the same though? So the diameters of the cookies were the same, and the brand, they were both Oreo brand. I could have saved money and bought generic for the regular ones, but then it wouldn't be the same because they're made of different companies. So having the same company was important, as well as the same shape of the cookie was important. So the only difference would be the filling. Okay, so now if I were to write a hypothesis, which this is kind of tricky because we're only looking at is it twice as much or not, so it's not the best hypothesis, but I would write something like, if I compare the mass of the filling between regular and double stuffed Oreos, then the filling in the double stuffed will not actually be twice as much because the height of the center is not double. So, while it's not the best hypothesis, it does have all the component parts. A hypothesis is an explanation that you can test. So, I'm using my observations that it doesn't look as high to try and explain myself. Okay, another example, we listened to chirping crickets. So I'm going to use the one where we looked at how does temperature affect rate of cricket chirping. And so what we are changing is the temperature. And then we are observing how many chirps each cricket makes at those different temperatures. So my independent variables of what we are changing as the researcher, and that was the different temperatures. I believe it was 14 degrees Celsius, 19 degrees Celsius, and 24 degrees Celsius. Then our dependent variable is what we were listening to, where we were observing and listening to the different chirps and recording that. Now our controlled variables are what we keep the same. In this one, when we were checking for the temperature, the humidity was the same for all of the crickets. So the humidity didn't change, and that was our controlled variable. Okay, so hypothesis, if crickets are placed in hotter temperatures, then they will chirp faster because they are ectotherms and can be more active in warm weather. So here, this is a hypothesis or an explanation that I can test. Now we also measured our lung capacity. So our big overarching question was, how does height affect lung capacity? So our independent variable, the thing that we are changing is basically the people's heights. The height of a person, because that's what we're curious about. Does height affect lung capacity? So what are we observing? Well, how much air the lungs hold. We exhaled through that spirometer, measuring the amount of air coming out of a person's lungs. And then we graphed it and recorded how does each height compare to its lung capacity. Now our controlled variables, the things we kept the same, we used the same machine each time, and then the same amount of time, or same time, let's just say same time of day, the same time of day, so it was all in second period in the morning, and then in sixth period, all the same time. Now the same amount of activity. We were all sitting in class when we did this, and so if I asked you to run up and down the stairs, or do a bunch of push-ups or jumping jacks, that would have altered our results, and so therefore everyone just moved from their seat to the breathing machine, and so therefore our activity levels were all constant as well. So really the only variable was our height. So if I was looking at a hypothesis for this, it would be if a taller person exhales, then they will breathe out more air because they have a larger rib cage and can therefore hold more air inside. So remember, a hypothesis is an explanation you can test. And then our next example from class was our paper airplanes. So in this one, we had choices on what we wanted our independent variable to be. So I'm going to use the example of the design. changing how I folded different shapes of airplanes. So what I'm observing, what I record, my dependent variable, was how far it travels. That's what I'm measuring. Now my controlled variables are what we keep the same. So if I was curious about the design and how that impacted how far it travels, I want to make sure I keep the type of paper, the same size of paper, and the force we throw it with all controlled or constant. Because if I change the type of paper, well, maybe it was the type of paper and not the design that impacted its distance, right? So you want to keep everything the same and only change one variable. So my hypothesis in this example would have been, if I change the shape of an airplane to make it more aerodynamic, it will fly farther because it will have less resistance as it flies through the air. Okay, good job.